NARFU Laboratory of Arctic Biomonitoring, established in 2017 as part of a Russian government-sponsored mega-grant project. Research areas: development of methodologies for monitoring, assessment, forecasting and prevention of risks related to transfer of toxic pollutants through biological pathways capable of accumulating in trophic chains and spreading in Arctic ecosystems. Objectives: mitigation of the economic and demographic consequences of health disorders in the Russian Arctic population occurring as a result of uncontrolled transfer of highly toxic polluting chemicals, hazardous contaminants to the environment. Chemical security efficiency improvement, development of national and regional systems of biological monitoring, forecasting and managing risks associated with uncontrolled spread of dangerous contaminants to the Arctic by migratory species of birds, fish and wild animals, biological pathways. The lab has its primary focus on persistent organic pollutants, the toxic chemicals with negative impact on human health and environment. Once POPs enter the high latitude through the cross-border biological pathways, they don't disintegrate. Instead, they accumulate in and migrate along the food chain, affecting people and wildlife far away from their sources. In order to reduce the economic and demographic consequences of the pollutants cause health deterioration in the Arctic population, the laboratory conducts research into the content of toxic elements in food consumed by the indigenous communities, whose diet is known to consist 80% of migratory fish and bird species vulnerable to toxic exposure. We have been able to accumulate extensive knowledge on soil, permafrost, ice and seawater pollution. At the same time, we were the first to start working with biological material, fish and birds. We are unique in that we began to analyze the possible impact of environmental contaminants on human health. The research conducted by the laboratory team has found that the effect the toxic substances in food have on health levels of the Arctic population is minor, unlike the lack of some particularly vital elements. Our target areas, Arkhangelsk region and Nenets Autonomous Okrug, are characterized by iodine deficiency. We have also found that anemia and iron deficiency are very common here. Those elements are predominantly found in food. That is why it is extremely important to develop dietary guidelines which can significantly improve the quality of life in the Arctic. Biological sampling can be an effort-consuming process and is crucial to the final outcomes. The laboratory team have been on more than 20 sampling expeditions to the Nenets and Chukotka areas. The samples they bring back are biological fluids of migrating birds and fish and human body fluids. The geography of the investigations is large enough to provide an exhaustive picture of the persistent pollutants ingress into the Arctic areas from western and eastern directions. The laboratory is installed with ample equipment enabling sample preparation and analysis using atomic absorption spectrophotometry. More in-depth analyses are carried out in partnership with NARFU Center for Shared Use of Scientific Equipment Arctica, which offers gas chromatographs for ultra-high measurement accuracy. We are lucky to be partnered with Arctica and its highly competent team, who are always ready to help us navigate through possible solutions or go over our test results. One of the tasks of the lab is to define the threat posed by persistent organic pollutants. As a rule, the risks include increased incidence of cancer, disruptions in endocrine and reproductive systems. There is a scientific theory arguing that prolonged exposure to pollutants may change the sex ratio of the population. In order to investigate such phenomena, the lab initiated an experiment with zebrafish, whose genome 3/4 coincides with the human one. The rapid growth, typical for the species, allows the researchers to trace the influence on a few generations within a relatively short time. The zebrafish are often utilized for researching the effect of various medications and pollutants. They are used worldwide to determine human risks. The lab's research priorities also include jurisprudence. A study of relevant legal practice revealed that cases of courts awarding compensations of health damage resulting from environmental factors are currently almost non-existent. That is why the lab also prioritizes the development of a methodology for environmental-related health damage compensation. This line of work is carried out as part of the comprehensive approach to Arctic biomonitoring challenges. Lawyers contribute by looking at the legal side of the issue and identifying gaps and ways to fill them. Doctors look at the risks to public health and measure the exposure to toxic elements and substances. Chemists do analytics, while ecologists and biologists go on sampling expeditions determining the species' age and sex. The laboratory also acts as a provider of training involving ecology, chemistry and biotechnology majors and PG students in its research task under the Mega Grant program. In 2017, the team of NARFU Laboratory of Arctic Biomonitoring was joined by Ingvar Thomassen, Professor of Chemistry, National Institute of Occupational Health in Oslo. A leading scientist, Thomassen acts as a research coordinator, master and PhD thesis supervisor, delivering also lectures to a broad range of audiences.
But you know that chemists, they can be used as potatoes for everything. So you may agree or disagree, or I may seed some ideas and add to your already basic knowledge.
In 2018, the laboratory held its first international conference titled Biomonitoring in the Arctic, covering a wide range of issues of environmental monitoring in high latitudes. Its proceedings were translated into English for publication on IOP conference platform, with papers indexed in Scopus and Web of Science. Today, the laboratory serves as a venue to bring together many of collaborative projects. Close cooperation is maintained with Mechnikov Northwestern State Medical University in St. Petersburg, High School of Economics in Moscow, University of Aberdeen, University of Tromsø, and University of Geneva. Negotiation is in process to start cooperation with scientists in Vietnam. Joint research work was conducted on board the Arctic Floating University with colleagues from South Korea. Collaboration is seen as a way to expand the range of research and to join efforts towards perfecting the techniques of Arctic biomonitoring.